Okay, so we're going to get started. Thanks for everybody for coming. We have a smaller group than usual today, but it's good to see the familiar faces who have come before and some new people who have come today. We actually were planning to have two talks, but our second speaker had something come up and he could not make it, so we will have a one long talk today. So we are banking on a lot of questions from you guys. So our talk today is on building BAM, a serverless framework, by Josie Moore, who is a software engineer and the co-creator of this open source serverless framework. So please welcome Josie.
Okay, can everyone hear me all right with that, like that? Okay.
Yeah.
All right, well, thank you. My name is Josie Moore, and I recently worked with a small group of developers to build a serverless framework called BAM. And you can use BAM to quickly deploy applications using Node.js and Amazon Web Services, or AWS. And I'm really excited to tell you about the framework tonight, but there's a few things that I want to get on the same page about first. So I'm going to spend some time going over the current landscape of serverless technologies. I'll get into some of the nitty-gritty details of working with AWS, and then I'll walk through some of the features and challenges of, that we encounter during development. All right, let's get into it. So what is serverless? Well, the word itself, serverless, is a misnomer because there are servers somewhere in the world. They're just abstracted away from you as the developer. Now what this means is that you have no addressable server to control. That's because a third party is managing this hardware for you. Now that's really cool because your list of responsibilities as a developer is a little bit smaller, but there is a trade-off. While you don't have to manage the server itself any longer, you do lose some control over how your code is handled and to some extent how it's structured. Now this area of server management that I'm talking about, it's not as black and white as I just put it. There are different deployment options. And you might be familiar with some of these, maybe one more than another, but you could deploy to Heroku, you could use a DigitalOcean droplet, you could use a Docker container. And what these different options are giving you is various levels of control over your code base and a certain level of abstraction of certain application lifecycle tasks. And these two things go hand in hand, which is exactly what this table here shows. And so we're going to go through it row by row, and just keep in mind that each option builds on the last. So we'll start at the top with bare metal. And bare metal just means the actual server machine itself. And with this option, because the least amount is abstracted away, it gives you the most control over your application. The next is infrastructure as a service. And the part that's abstracted away with this option is that server machine. So you do have to manage everything else, including the operating system. Next is containers as a service and platform as a service. And the line between these two options can get kind of blurry, but essentially with containers as a service, your code is deployed to these encapsulated containers, as the name suggests, and those containers share one hosted operating system. Now with platform as a service, even more is abstracted away, and depending on which one you choose, you might not have to worry about certain things like logging, or security, or storage even. Now on the last line, you'll see two options, functions as a service and backend as a service. And these two options are together on the same row because these are really the two things, the two categories that people are talking about when they say serverless. And it's what we're going to dig into more over the next few slides. So functions as a service. With functions as a service, you as a developer write small pieces of functionality that you deploy to these ephemeral containers that live in the cloud. And one notable drawback of working with functions as a service is that it's not easy to persist state in between function invocations. And this is something I'll get into at a later point. An example of functions as a service would be AWS's Lambda service. Now, backend as a service, on the other hand, with this option, you as the developer use a hosted service that will handle one component of the backend. And there are many types, including services like Auth, which will handle authorization for you, Amazon Simple Storage Service, or S3, which handles storage, as you might have guessed, Google Firebase, which is a cloud-based database, and there are many more. So what are the advantages of working with serverless technologies like functions as a service or backend as a service? Well, because these modules of functionality can be easily swapped out, iterated on, and redeployed, they really enable for easy experimentation and rapid development of your application. Also, the cloud resources are provisioned on an as-needed basis, so frequently the fee structure is pay-as-you-go. Serverless technologies are also ideal for situations where you have large variations in traffic and when you don't have the capacity to manage servers yourself. There are many providers of serverless technologies, including these I have listed here: AWS, Microsoft, Oracle, Google, IBM, and there are more still. But the BAM framework supports AWS only, and that's because AWS is one of the most prominent providers of serverless technologies currently. It's supported by a large community of developers and offers a wide range of services to choose from. Now, ideally, working with a serverless provider like AWS or functions as a service like AWS Lambda would make your development process easier and faster. But in reality, that's not the case. The AWS console, the command line interface, and the software development kit, all this tooling can be quite clunky. And all those services that Amazon offers, they each have their own jargon and configuration that you have to know in order to accomplish what you're trying to accomplish with your application. On top of that, a task that might seem discrete actually consists of a long series of subtasks or microtasks. And to show you some of this complexity, I'd like to walk through an example of working with AWS Lambda and Amazon API Gateway. So to give you some context, let's say that we have a coworker who's a sales manager, and this person wants to view some company data, like a sales report for the month of November 2018. And this person comes to you for help, a developer. How do you help them? Well, you have a couple options. You could manually query the database. You could write a script to query the database, say, for instance, if they wanted that information for a number of accounts. But both of these options feel tedious and time-consuming, especially if that person comes to you frequently for a different variation of this information. So this is really where you could use an AWS Lambda and an API Gateway. You can use the Lambda to query the database, process that data, format it, and then use an API Gateway to expose that information via a GET request so your coworker can view that in a browser. So we're going to walk through the sequence of steps required to deploy an AWS Lambda and integrate it with an Amazon API Gateway. And we're going to walk through the steps required to use the SDK. Now this might seem a little complicated, so just bear with me. As a heads up, here are some of the symbols that you're going to be seeing really throughout the rest of the presentation. They'll be labeled on those slides as well, but I wanted to give you a quick overview of what they represent beforehand. So starting from the left, there's the symbol for AWS Lambda, so Amazon's version of functions as a service. The yellow symbol is the symbol for Amazon's API Gateway, which we'll be using to create an endpoint that we'll want to give to our coworker. The third symbol, the blue one, is for Amazon's DynamoDB service, and this is Amazon's NoSQL storage solution for key value pairs and documents. The fourth symbol is an edge location, which is a data center within the Amazon CloudFront network. And the last symbol, the green one, is an AWS IAM service, which stands for Identity and Access Management. It's one of the services related to security that Amazon offers you, and specifically related to authorization. Additionally, we're going to be using one of two AWS service objects in order to issue the relevant SDK methods. And you'll see this represented on the slides as either the word Lambda or API. So the first method that we need to call is Lambda's create function method. And this will use a zip file to deploy the Lambda to the cloud. We'll have to provide some additional parameters, of course, but one important one I want to point out is an IAM role. And an IAM role gives access to the Lambda or gives permission to the Lambda to interact with other AWS services. The next method that we need to call is the API Gateway Create REST API method. And this creates an API Gateway object, giving you a root resource, which represents the root path, or the slash, which is highlighted here in blue. Now, if we want our API Gateway to support path parameters, we're gonna need to make an additional resource for the greedy path. And the greedy path is represented here by the phrase proxy plus, and it's essentially the part of the URL path that comes after the slash. So in the example at the bottom of the screen, it's the part in bold, the 2018/11. And the part of the URL path that includes and comes after the question mark, that's a query parameter. So in order to do this, we need to call the API Gateway Create Resource method. And even this is a complex operation because one of the arguments we need to pass in is an ID for the root resource. And in order to get that, we need to call another method called getResource in order to get that ID. And the reason why we need to do this is because the greedy path resource is a nested child of the root resource. So to review, we have a Lambda that we've deployed to the cloud, we've created an API Gateway object, and we have two path resources, one for the root resource and one for the greedy path resource. So the next three steps we need to perform in order to add a get method to the root resource and integrate that with the Lambda. We'll have to repeat these three steps in order to add a get method to the greedy path resource and integrate that with the Lambda. Additionally, if we were going to add other HTTP methods, we would need to repeat these three steps for those as well. So the first of the series we need to call is the Lambda add permission method. And this gives permission to the API Gateway to invoke the Lambda. Then we use the API Gateway put method to add the get method to the root resource. And then we call the API Gateway put integration method to create an integration between the root resource and the Lambda. Now, an integration, just generally speaking, is a way to take an incoming HTTP request to an API Gateway, maybe do some processing, and pass it along to another AWS service. There are several different types, but if we want to expose as much of the request to the Lambda, we want to use an integration called Lambda proxy. So like I said, we need to repeat those three steps to add the get method now to the greedy path resource. So we add permission for the endpoint to invoke the Lambda. We add the get method to the greedy path resource, and we create an integration between that resource and the Lambda. Finally, we can call the API Gateway create deployment method. And this will bundle all of that, all of those methods and resources and integrations into one deployment resource. Only now do we have a callable endpoint that we can give our coworker for them to view the data that they asked for. So that's a lengthy process and there's no need to memorize it or anything. But what I want to point out is who wants to do that every time they want to deploy one Lambda and integrate it with one API Gateway? No one, I hope. So the developer community has created a number of different frameworks in order to simplify this interaction with AWS. Now, these frameworks, they exist on a spectrum. Some are more complex and better suited for enterprise applications, and others are simpler and better for smaller applications. You'll notice three frameworks in addition to the BAM framework on this slide, and that's because in our research, we focused on the Serverless Framework, the Claudia.js framework, and the Shep framework. So what I want to do now is take a look at how to do what we just did with all those SDK methods, and how to perform that exact task, or do that exact task with each of these frameworks and compare and contrast them. So we'll start with the most well-known. It's the Serverless Framework. And the name is confusing. They did name their framework after the technologies that they're using, kind of like the Kleenex of serverless technologies. And this framework can handle quite a bit of complexity. And so it's better to use when you have a larger application. Some of the advantages of working with the Serverless Framework is that it supports a variety of providers and it offers you a wide range of functionality. In terms of working with Lambdas, it offers you prefabricated Lambdas to use and templates that you can alter. Now, some of the disadvantages of working with the Serverless Framework is that in order to configure your AWS resources, you have to interact with a YAML file, which can get kind of finicky with the syntax. Also, it creates many AWS resources on your behalf, even for a simple task like this. And that's only a disadvantage because of how AWS charges you. there is a free tier for most services, but there's no barrier that prevents you from exiting that free tier. Lastly, it takes approximately 2 minutes on average to deploy a dependency-free Lambda and integrate that with an Amazon API gateway. So all in all, the serverless framework is a full-featured framework, but it can feel just as complex as working with AWS. So we'll take a look here at the deployment process with the serverless framework. You'll notice here in a second, it's necessary to edit that YAML file, and it's just going to be a quick copy-paste right here, because this GIF could have been forever, could have taken forever. Now also here in a second, it's going to start creating a number of those AWS resources. So it started right there with the CloudFormation resource. So we're not going to watch the whole thing. We'll move on to the Claudia.js framework. So the Claudia.js framework offers you a lot of options as well. It was optimized for deploying APIs, and some of the advantages of working with this framework are that you can also configure your AWS resources in a number of different ways. It gives you specialized modules like the Claudia API Builder and the Claudia Bot Builder, and it's simpler than working with the serverless framework. Some of the disadvantages of working with this framework are that those specialized modules, they require separate installations. You also have to work with a package.json file to manage your dependencies, and it only supports AWS and Node.js. Lastly, it takes approximately 1 minute and 15 seconds to deploy one dependency-free Lambda and integrate that with an API gateway. So all in all, lots of functionality with the Claudia.js framework. So here's the deployment process with the Claudia.js framework. And you'll notice right off the bat, it's necessary to use the npm and init command in order to create a package.json file for that dependency management. So it's going to start to do a number of different things here. And just like with the serverless framework, we're not going to sit through the whole deployment process. But we'll move on to the SHEP framework. The SHEP framework is a very simple framework. It actually was designed for this exact use case of deploying Lambda and integrating that with an API gateway. Some of the advantages of working with this framework are that there are very intuitive prompts that you can work with in the terminal, and you can deploy multiple Lambdas at once. Some of the disadvantages of working with this framework is that the SHEP framework is opinionated about how you organize your Lambdas into certain projects. It also, how it manages dependencies, a function that you've created that's say 20 lines of code can actually turn into hundreds of lines of code when deployed to the cloud. It offers limited configuration, it only supports AWS and Node.js, and it also takes about 2 minutes to deploy a dependency-free Lambda and integrate that with an API gateway. So here's the deployment process with the SHEP framework. You'll notice right off the bat some of those intuitive prompts that I mentioned. It's ironic that it's taking so long to install dependencies because this is a dependency-free Lambda. But as a framework, we felt that SHEP really could offer a few more conveniences and a little more flexibility, even though it's perfect for this exact situation. So this is really where the BAM framework comes in. Not only can you deploy a Lambda and integrate it with an API gateway, but it's optimized for this. Some advantages of working with the BAM framework are that there are templates that you can use to help get going very quickly. It's not opinionated about how you organize your Lambdas into projects. You can persist data in between Lambda invocations, which I mentioned as a drawback of working with functions as a service earlier, and I'll explain how the framework achieves that later. And it takes 20 seconds to deploy a dependency-free Lambda and integrate that with an API gateway. So quite a difference from the other frameworks that we were just talking about. Some of the disadvantages of working with the BAM framework are that it offers you limited configuration and it also only supports AWS and Node.js. So here's the deployment process with the BAM framework. And you'll notice that it's not necessary to navigate between directories and there's no configuration necessary. So that URL is going to repeat now, it's going to loop. But that URL at the end there, that is the endpoint that you would give your coworker to view the data they asked for. So what happens in the AWS infrastructure when your coworker visits that URL? That's what I'd like to get into next. So your coworker will take that URL, copy paste it into the address bar, and that request will be sent to an edge location. Now remember, an edge location is a data center within the Amazon CloudFront network. Now I should stop here and mention two things. One, there are several different types of endpoints, but usually an edge optimized endpoint is best. And that's because it does exactly this. It'll route the request through the CloudFront network and give it a performance boost. The other thing I wanted to mention is that an edge optimized endpoint is public by default. Now that's not a problem if you're creating a public web page, but if you're dealing with private company data like we're talking about in our example, it's important to know that the BAM framework assumes that you're taking whatever measures necessary to secure your AWS resources. There are a number of different ways to secure an application, and this really just allows you or your company to choose what's best for you. Okay, so that request then gets routed to API Gateway. An API Gateway has to check that it has permission to invoke the Lambda, so it reaches out to AWS IAM. Hopefully, a successful response is returned, and the API Gateway can invoke the Lambda. Now, the Lambda can do any type of processing that it's programmed to do. It can even invoke another Lambda. In our case, it's going to reach out and query a database for the total sales for the month of November 2018. That data will be sent back, and if you're using the BAM framework, you can create a DynamoDB table to persist data in between Lambda invocations. And an example of some data that you might want to persist would be metadata or timestamps of when this URL is accessed. So either way, whether or not you use this feature, the response will be routed back through API Gateway. And because we're using Lambda proxy integrations, that response has to be a JSON formatted response so that the API Gateway can transform that into the proper HTTP response. And then the response gets routed back through the edge location and to the user who can view the sales report in their browser. So again, that was a lot, and all of this complexity the BAM framework handles for you. I hope at this point in the presentation you can appreciate that there's much to gain from working with serverless technologies and the ease and speed with which the BAM framework gives you access to these beneficial services. So for the rest of the presentation, I'd like to walk through the features of the BAM framework and some of the challenges that we encountered. So first and foremost, the BAM framework was built as a robust command line interface. So each BAM command captures more functionality than any one AWS SDK method. Now a lot of these commands are self-explanatory, but I'll just walk through them real fast so that you can kind of get an idea of what you can do with the framework. So there is the deploy command, which deploys a Lambda and an API gateway, which is what we just saw. There's the redeploy command, which allows you to update a Lambda and an API gateway. The create command allows you to create a local file or directory based on a template. The list command lists all of your Lambdas and all of your DynamoDB tables that you've created with the BAM framework. There's the get command that allows you to pull down a Lambda function created elsewhere to your local machine. There's the DynamoDB table command that allows you to create a DB table command that allows you to create a DynamoDB table. There's the delete command to delete a Lambda and an API gateway, and the config command to update your default user settings. Now, the framework was created with a number of opinionated defaults that is really what makes it so fast, but also a certain degree of flexibility. Most of those commands that I just went through also can be issued with a number of different flags so that you can customize the operation you're trying to perform. I'm not going to walk through all of these here, but I'll walk through a couple of examples. So the deploy command has a Lambda only flag, so you can deploy just that Lambda. And to complement that, the redeploy command has an add endpoint flag, so that you can later add an endpoint to that Lambda. Additionally, the create command takes a number of different flags that allow you to create different templates so that you can really get going quickly. No flags will create the basic template, and the basic template exposes the HTTP methods, the path parameters, and the query parameters. And all of the other templates are based off of this one. The invoker flag will expose the parameters and the payload response when invoking another Lambda. The DB flag will give you a doc client object, which allows you to interact with the DynamoDB table more easily. And there's an HTML flag, which allows you to write HTML, CSS, and JavaScript that will be exposed through the Lambda. And you can also create these templates with instructional comments if you use the verbose flag. But if you're already comfortable writing Lambda functions, you don't have to use any of these flags any of these flags in order to use the BAM framework. If you're interested in reading a little bit more information about these details, please take a look at the BAM documentation. So another user-friendly feature of the BAM framework is that there's no configuration necessary. You don't have to interact with a JSON file or a YAML file in order to configure your AWS resources. You can literally install the npm package, and if you already have the AWS CLI installed and a Lambda function ready to go, you can right away use the BAM deploy command. So how does the BAM framework do this? How does it achieve it? Well, it'll find the information it needs automatically. So for instance, your account number. It needs your account number in order to create AWS resources on your behalf. And what it'll do is it'll call an AWS SDK method for working with Amazon Security Token Service, or STS. And in this way, it doesn't have to directly access your access key or secret access key. Now, this design sacrifices some degree of configurability, but it does really allow the developer to get going quickly without having to understand all the nuances of working with AWS. So similar to how the framework handles configuration, it's also smart about how it handles dependencies. So a developer doesn't need to create a package.json file and manually install these dependencies. All they need to do is include the appropriate require statements at the top of the Lambda function file. And when you're ready to deploy, the framework will copy that Lambda function file into a hidden staging directory. And there, it will parse the file and detect the dependencies, create a package.json file, determine which dependencies are non-native node modules, and install them, and then zip all of those files together as the argument that it provides to the create function method we talked about earlier. So this gives you two things. It allows you to organize your Lambdas however you want. You can put them all into one directory, you can organize them into different projects, it doesn't matter. As well, it also prevents that deployment payload from being bloated with unnecessary dependencies that might be there from local testing. So here's a diagram of how the BAM framework interacts with the local file system to enable this process. The first time you issue a BAM command, it will create a hidden BAM directory, which is the medium gray envelope you see on the screen. Inside that, it'll create a hidden staging area, that's the dark envelope that you see. It'll also create a number of JSON files in order to keep track of certain metadata about the Amazon resources you've created using the BAM framework. Now, BAM does this all behind the scenes in order to avoid cluttering your working files. AWS resource modification. So the BAM framework doesn't assume you'll only be using the BAM framework. And this was something that we wanted to support as a feature, as well as ran into as a challenge. As a feature, we wanted to enable developers to create a Lambda function file in the AWS console and be able to pull that Lambda function down later to their local machine for updating and redeployment. And that's exactly what the get command does. Now, as a challenge, we ran into this because during development, the role that the framework creates for you on your behalf so that you can perform these operations in AWS by accidentally got deleted, and all subsequent BAM commands failed. So in order to prevent this from happening for an actual user, what happens is the framework will first check that that role exists, and if it doesn't, it will automatically recreate it for you before trying any of those operations. So as much as possible, the BAM framework won't break if you've made changes in the AWS console. There are a number of other interesting challenges that we ran into. One is related to one of the known drawbacks of working with functions as a service, and that's persistence. It's not easy to persist state in between Lambda function invocations, and this is due to some of the mechanics of how AWS Lambda works. So when your Lambda function is called, what happens is a server is spun up somewhere in one of the server farms that Amazon owns. And the Lambda will do whatever processing it's programmed to do, and if that Lambda function is not called again after a certain amount of time, that server will go cold. So any global state will be lost. Now this is great for auto-scaling, but not great for persistence. So the solution here is to offload that responsibility of persistence to a second service. For the BAM framework, we chose to use DynamoDB, which again is Amazon's version of NoSQL storage. And the reason why we chose DynamoDB over, say, another database service like RDS, Relational Database Service, is because DynamoDB is easy to set up. It doesn't require a lot of configuration, and the schema doesn't have to be defined ahead of time. It's also really flexible. It can be set to auto-scale as the Lambda function invocations increase. Now, the last two challenges are kind of the same nature. They're timing issues. Because the BAM commands encapsulate more functionality than any one AWS SDK method, a certain operation within that sequence actually depends on the state generated by a previous operation. And this is where we notice latency and rate limits. We noticed a latency from when a resource was created in one service and when that state was propagated to other AWS services. And additionally, AWS throttles certain operations. For instance, you can only delete one API gateway every 30 seconds. So if you have a sequence of operations and you hit that rate limit, again, it'll cause a failure. Now, one important thing to note is that these traffic jam-like problems can be exacerbated by geographical proximity to the data center that you're trying to interact with. So how does the BAM framework handle this? How does it work around these limitations? Well, we noticed a specific type of exception with each scenario. So with the latency issue, we noticed that we were receiving an invalid parameter value exception. And with the rate limits issue, we were receiving a too many requests exception. So the solution is quite simple, actually. There's a function called BAM that will gracefully retry calling the SDK method behind the scenes until Amazon's system is ready and prepared to handle that operation. So here's a visual diagram of how BAM handles rate limits when deleting an API gateway. So BAM will call the SDK method to delete the API gateway. It will try to delete the resource and get throttled and return a too many requests exception. BAM will wait a certain interval of time. In this case, it'll wait 15 seconds before retrying that SDK method. So if at first it doesn't succeed, it will try again until eventually this loop will be exited, either because the operation worked or because another exception was thrown. So that concludes my overview of the BAM framework as it is today. But because software is never truly finished, we have a couple of other ideas that we'd like to incorporate in order to further improve the developer's experience of working with AWS via the BAM framework. So we'd like to add support for CORS, or cross-origin resource sharing, so that you can call that endpoint from another application. And this is something that you can easily enable currently in the AWS console, but it would be great to incorporate this into the framework itself. Additionally, we would like to add support for S3 so that you can include other front-end assets like images. And as of the end of last November, Amazon added support for a few other runtimes and now supports Java, Python, Ruby, even custom runtimes, and it would be great to support another runtime in addition to Node.js. So thank you. My name is Jossie Moore. I'm one of the 3 authors of the BAM framework, and I'm available for any questions if you have any. If you're not comfortable asking in front of the group or you think of one later, please feel free to reach out to me. My email is hello@jossiemore.com. And if you're interested in reading more of the details about the framework, you can check it out at bam-lambda.com. Thank you. Yes.
You were mentioning at the end, you were talking about the throttling and the messages that go through, and that doesn't seem like it really increases the time. I mean, that it resolves the time issue of trying to delete more than one. Is there any thoughts of trying to improve that by maybe putting that inside the gateway and then getting over the wall first and then deleting the multiple gateways?
I'm not sure I followed the last part, but I think what you're talking about is actually changing how AWS works, but maybe I'm wrong. So
sort of, but getting around it by instead of sending 5 requests in from the front end, send one request where the request is the 5 things, so that it gets one request, but the one request deletes the 5.
So like you using Lambda in that case, maybe to delete the API gateway. Is that what you're suggesting?
Yeah.
Yeah, that could be an idea. And that way, yeah, not so many requests happening from the framework itself.
So this tool, this framework is mostly CLI. Is there, because the Lambda is something which is like if you are targeting a developer, so is there a plan to have this like some kind of a plugin to the IDE as well? Or
No plans yet to incorporate. The question was any plans to incorporate using Lambda.
editors or IDE or like
Yeah, via the IDE, and we haven't. That's not something we've talked about yet, but definitely something we could incorporate.
Is BAM the most popular out of all the frameworks?
No, it's very new compared to the other frameworks. The most well known is the Serverless Framework, and that definitely has the most functionality. Supports many different providers, not just AWS. BAM is a very specific use case. It's more on the other end of the spectrum, so for a simpler use case. Yes?
Why you retrying the delete after 15 seconds when Amazon is allow only after 30 seconds?
It's somehow it's related to the timing of it. So it's from the last time you deleted an API gateway. So you can delete an API gateway in another way, say on the AWS console, and then use the framework. But the last time you deleted it wasn't 30 seconds from when you last issued the BAM delete command from the framework. It was the last time. So it's not just from the framework. It's not the timing from just the framework.
Okay. And I noticed that in certain slides you say 2 minutes or 1 minute and 50 seconds is a disadvantage. So why is that? That means people are using more and their response times will be very fast. Why 2 minutes considered too slow?
Yeah. So it felt slow, just sitting there waiting for 2 minutes. And imagine like Lambda, you can have many Lambdas that you can be deploying and updating throughout the day. And waiting 2 minutes for that to happen just felt like a long time, and something that an aspect we wanted to improve on. The reason why, I can't say exactly why, but some of the reasons why it takes a little bit longer is because those frameworks are doing more behind the scenes than what the BAM framework is doing. And additionally, the BAM framework has a number of defaults, opinionated defaults that you can't change as a user. Which means they're not required to configure that at deployment time. So it's much faster in that way as well. Yes?
You sort of went through comparing the frameworks for kind of the create function case, and I was kind of curious what happens when you update your function and you want to redeploy it, how the frameworks handle that.
Yeah, that wasn't something that we benchmarked as specifically, and they do require different. They have different mechanisms for redeployment and updating, so they didn't feel quite like comparing apples to apples.
Sure.
But yeah, there's certainly a lot of functionality that's different and similar between the different frameworks that we could have benchmarked as well. But yeah.
I can see it being a complicated problem, especially in the more configurable frameworks, if it's trying to kind of converge, like I change
Yeah.
this one setting.
Yeah, exactly.
It's almost like a Terraform kind of situation.
Did I see another question over here? Yes.
So what this framework can do is that some of it are also possible using Terraform against AWS.
I haven't used Terraform. That's not something I've done myself.
Okay.
So I'm not. Do you mean use it with Terraform or
No,
use it
just using
instead?
Terraform to define what state I want my function to be in, and this is the API gateway fronting it, and this is how it is associated with each other. So writing a Terraform file and just do a Terraform apply on
Yeah. So that reminds me kind of similar to how like using the JSON file or using a YAML file to configure the AWS resources in some of the other frameworks that we did kind of test out and explore. And that was a piece that we wanted to take out and make it just a lot easier for someone who just wants to get going quickly, just wants to explore using serverless serverless technologies, greenfield application developer who's not ready yet to dive like headfirst into all the documentation, or work with, we could have templated those configurations similar to the other frameworks using JSON or a YAML file, but as a new user, some of those files felt very overwhelming to be like, oh, what are all these levers I can pull? And so just by narrowing that down and simplifying that for the person who just wants to like go and just wants to see what it's like and explore it, paring all that down to just what was essential felt important and make it a lot easier and faster.
So you mentioned there's set up defaults, right? Can you change those defaults to templates or no?
In the templates?
Yeah.
In the templates, there's a number of things that you will need to configure, not configure, but set up in order to make the template work how you would need it. There's one setting that you can set, which is your region and the description for the Lambda, but the only way to change, you can use the config command to change and update your user settings, a few of them, and the other opinionated defaults, those are kind of locked in place. There are certain workarounds that you could, kind of hack it and change by like updating. For instance, you could change your region if you opened up the hidden config file, which the AWS CLI sets up for you when you configure that for the first time. So that's a way that you could change your region, but that's not something that we allow or support changing via the BAM framework right now. Just because it felt like, again, for the user that we were targeting, someone who just wants to get going quickly, doesn't need to change their region. Might even be like, what is the region? Might be at that level, and not know how to use it. And so by kind of taking all that noise out, that's really what it does. That's really what was the purpose. But you can kind of get around it in that way.
So how does it pick the region? Does it based on speed? Does it
That's a good
talk
question.
to a discovery service? Or?
So when you set up the AWS CLI, that does require some configuration, and one of the things you need to configure is your region. So it will give you, I believe it gives you a default region. It's been a long time since I did that, but again, you can always change that via the AWS CLI. That's one of the prerequisites to using the BAM framework.
So it's not something you discover automatically.
No, not something you discover.
So have you seen situations where AWS in general would make changes to their roles or policies? How easy would it be once I deploy this framework to go edit and in terms of manageability of this framework itself?
Yes.
It changes in reaction to what happens on the AWS side.
So I just want to make sure I get your question right. Is your question about how the BAM framework adjusts to when AWS changes, or how you can change the role?
How you can go back and modify, say somebody deploys this framework, right, to create this, deploy the Lambdas, and the AWS itself is changing. Like AWS is hearing all the complexity, right? It wants to make it simpler, or it wants to give you a lot more flexibility. So how would you go back and change this framework to support that? Have you seen those big changes happen?
Haven't seen specifically those changes in terms of IAM roles. Since starting development on the BAM framework, the Lambda layers has come out, which Lambda layers, basically you can say you have two Lambdas and they have the same dependency. Instead of including those dependencies in those deployment packages, a layer allows you to share that one dependencies between the two Lambdas. So you're limited to 5. So 5 dependencies that you can treat and create a layer for and share amongst all your Lambdas. But there is kind of a trick to it. At this point, a layer, the size of the layer is also included in sort of the max deployment size for the Lambda as well. So it really, from what I gather, I haven't used it. It doesn't. I haven't used it yet with any of my Lambdas, but it seems like it really makes it faster for deploying Lambda because you don't have that extra dependency in there. So there has been some changes, and I feel like it's a continuous conversation between the three of us to be like, that was an interesting challenge, kind of throughout from the beginning of development. Is like what to include and what to kind of like draw like hard lines of like that's not going to be included in the framework because AWS is just so extensive and is always changing. And not to say that the BAM framework is locked and won't change, but just that was an interesting challenge to really because we could have taken this as far as the serverless framework has and include all of this complexity, but at the end of the day, then we kind of missed our user that we were aiming for from the beginning. Because the serverless framework does feel as complex sometimes as working with AWS. Any other questions? Yes?
So I noticed you're a nonprofit?
Yeah, we're not doing this for a profit at this point.
Right. So are you planning to open source this then at all? Or?
It is an open source framework.
So you're up on GitHub then?
Yep. You can fork it, you can pull it down, you can explore it, please do. You can send us issues, like if you discover a bug, as much feedback as possible if you try it out would be great.
And do you have plans to expand to GCP, Azure, the other cloud?
That was something we talked about from the very beginning, but at this point that was one of our hard lines of like, we're gonna keep our focus small and narrow. But like I said, I would love to add support for other runtimes. That feels very accessible at this point. I see another question here.
Yeah, just wondering, does AWS throttle you on deploy too, or just
There's a handful of operations, and I don't have them all off the top of my head. Actually, the link I have in the slide does lead to the page where it lists out all the operations and throttles related to API gateway. Deploy is not one of them. Delete's one of them. Check in with me after. I can follow up with you about some of the other operations. The delete was the most extreme though. Some of the other ones were like once every 5 seconds. The delete was kind of the one that hit us hard once every 30 seconds. Yes?
Kind of a follow-up to supporting the other runtimes. I was just curious, how easy is it to move between different, do people kind of develop on Lambda and get locked in, do you find, or is it fairly easy for them to move to a different Azure, say, or GCP?
Oh, so a different provider. So a different runtime meaning like, someone wants to create a Lambda in Ruby, someone wants to create one with Node.js, but a different provider.
Yeah,
I'll take. I have heard a lot of people, being nervous about getting locked into a certain provider. And that was definitely a part of the conversation early on was how to, can we support another, how to support another provider. It's not kind of in the conversation right now, just because I feel it's so different between how the different providers handle Lambdas or functions as a service.
It seems like it could be a major use case to drive people to a framework like this if they want to
Yeah.
state themselves.
I haven't dug into it, but I'm really kind of curious to kind of get into the weeds with serverless. The serverless framework is also open source, so you can check it out as well. But it seems like a very kind of crunchy, gnarly problem to tackle.
Yeah.
Great. Well, thanks for coming out tonight. And again, if you have other questions, please feel free to reach out or just come up afterwards.
Thank you, Josie.
Yes.
So we don't have a second talk today, as I mentioned, because the speaker had to cancel at the last moment. So we have a lot of time to ourselves to network. If you want to get home early, that's cool too.
Well,
Yeah.
well, the speaker come back for another session though, because I'm kind of hoping.
You are
to see
interested in that
more
talk?
for-
Yes, so he is going to be available to talk at a different meetup, hopefully on the next one.
You.
Yeah, and we'll ask him to bring donuts.
Thank you.
And if there are people here who would like to speak on whatever you're doing and how you're using cloud native technologies, it could be as simple as, you're trying to migrate and this is what you've learned. So any knowledge that you can share, that would be good. So let me know. You can post it on, send me a message on Meetup, or you can put it on discussion also. Thank you.